So today we are going to do the experiment coffee cup calorimeter using dilute HCl and dilute NaOH. So in thermochemistry, a coffee calorimeter provides a simple and effective means to measure the heat of a chemical reaction occurring in solution. So this setup is particularly well suited for observing exothermic or endothermic changes in temperature, especially during neutralization reactions. So in this experiment, the coffee cup calorimeter is constructed using two nested polystyrene styrofoam cups, which serves as a low-cost and insulated reaction vessel, so which minimizing the heat exchange with the environment. So the primary objective of the laboratory activity is to determine the enthalpy change delta H of a neutralization reaction between dilute hydrochloric acid and dilute sodium hydroxide. So both chemicals are strong electrolytes and dissociate completely in aqueous solution, so which makes them ideal reactants for a standard enthalpy of neutralization determination. So upon mixing equal volumes of the dilute acid and base within the calorimeter, a temperature rise is observed, indicating an exothermic reaction. The heat release is absorbed by the surrounding solution and the temperature change is recorded using a thermometer. By applying the principle of conservation of energy and using the formula Q is equal to mc delta T, where m is the mass of the solution, C is the specific heat capacity, and delta T is the temperature change. So the total heat involved during the reaction can be estimated. So this experiment not only provides hands-on experiments with calorimetric techniques, but also deepens the understanding of energy changes in chemical reactions. So through careful measurement and observation and calculations, the students can connect the theoretical thermodynamic concept with practical laboratory skills. Thank you.
In this experiment, we demonstrate the use of a coffee cup calorimeter to study the heat release during a neutralization reaction between hydrochloric acid and sodium hydroxide. To begin, assemble a simple calorimeter by nesting two styrofoam cups together for insulation. Cover the top with a plastic or a cardboard lid that has holes for thermometer and a stirrer. Measure 25 milliliters of dilute hydrochloric acid and carefully pour it into a calorimeter. Record its initial temperature. In this case, the acid is at 35 degrees Celsius. Next, measure 25 milliliters of sodium hydroxide solution in a separate container. Now, quickly but carefully pour the sodium hydroxide into the calorimeter containing the hydrochloric acid. Immediately cover the calorimeter and gently stir the solution to ensure uniform mixing. Observe the temperature change. In this setup, the temperature rises to 43 degrees Celsius, indicating that the neutralization reaction is exothermic, that is, it releases heat. Record the final temperature and use the data to calculate the heat evolved during the reaction using the formula Q is equal to m into C into delta T, where m is the total mass of the solution, C is the specific heat capacity, and delta T is the change in temperature. This simple calorimeter setup allows us to estimate the energy change during an acid-base reaction in a controlled and safe manner.
So now let's look into the calculations of coffee cup calorimeter, and the equations we need here is the equations of heat and the equation of enthalpy change, which are Q is equal to mCp delta T and delta H is equal to minus Q by N, and the minus sign here represents that the reaction is an exothermic one as the coffee cup calorimeter releases heat. And where Q is the heat released, M is the mass of reactants, Cp is the specific heat capacity at constant pressure, T1 is the temperature of diluted HCl, and T2 is the temperature of the final mixture containing diluted HCl and diluted NaOH. And delta H is the enthalpy and N is the number of moles of limiting reactant. Now let's see what are the known values here. So we know that the Cp for this reaction is 4184 joule per kilogram Kelvin, and delta T is T2 minus T1. So here the values we have got is 43 degrees Celsius as the final temperature and 37 degrees Celsius as the initial temperature. So when it is converted into Kelvin, we can see that the values are 316 and 310. So the difference delta T is equal to 6 Kelvin, and as here delta T is greater than 0, we can say that heat is released during the process. And let's see what is the mass of the total solution. So mass of HCl is calculated as the volume into density. So the values are 25 ml, and the density of water is taken here as it is a diluted solution. Similarly, the mass of NaOH can be calculated, and we can see that both of them has the value 0.025 kilogram, and by adding both of them we can get the total mass as 0.05 kilogram. And let's consider the reaction HCl plus NaOH giving NaCl plus H2O. If both are 1 mole per liter solutions, moles of HCl can be calculated as 0.025 into 1 mole per liter. That means 0.025 moles. And the moles of NaOH is done by the same way. So here we have already calculated all the values that needed to be substituted. So let's see the equation. Q is equal to mCp delta T. Here mass is 0.05 kilogram and the Cp value is 4184 joule per kilogram Kelvin and 6 Kelvin. So by multiplying this we get the value as 1255.2 joules. Converting it to kilojoules we will get 1.2552 kilojoules. And let's see what the final enthalpy change is. So delta H is equal to minus Q by N, which is equal to minus 1.2552 kilojoules per 0.025 mole, which will give you the answer of minus 50.208 kilojoule per mole.
So I'm here to say about safety measures for a coffee cup calorimeter. Then first, let's see what we have to wear during the lab. So we have to wear safety goggles. It will protect our eyes during the experiment if there is any spill or there is any discharge from the reactants we are using. Then we have to wear the lab coat and chemical resistant gloves. Also the shoes are necessary to keep us safe. And then let's see what are the preparation and handling of chemicals. We have to use the dilute solutions only to minimize the risk, and always label all the containers. Don't misunderstand any reactants. It will lead to a higher explosion and it will risk our life. Also never taste or directly smell any of the reactants in the lab. Also during the experiment, assemble the coffee cup calorimeter securely and pour the chemicals with all the safety measures. Also make sure all your teammates are also under the safety measures.
A spill of reactants in our skin, we must wash it immediately for 15 minutes. The right way to dispose of the waste is to neutralize the reactants. Do not eat or drink or apply cosmetics in the lab. And keep long hair tied back and avoid loose clothing or jewelry. Familiarize yourself with the location of fire extinguisher, eye wash situation, safety shower, first aid kit.
The coffee cup calorimeter experiment demonstrated the principles of calorimetry and energy transfer in an acid-base neutralization reaction between dilute HCl and NaOH. By measuring the temperature change, we calculated the heat of neutralization using Q is equal to m into Cp into delta T, and the results were consistent with the theoretical enthalpy of neutralization. So the experiment showcased the effectiveness of the calorimeter setup and highlighted the importance of precision in thermal measurement.